Hello guys, am I audible? Hello, hello. Okay, nice. Yeah, so this is the editorial or PCD for the Starters Contest 184, and we will discuss the first four problems in this PCD. So let's start with the first problem, one down. This problem says that we have been given two binary strings s and t, each having length n, and we wish to convert s into t using the following operation any number of times. The operation says that we can choose two distinct indices I and j such that both of these si and sj are 1 and change both of these to 0. We have to determine whether we can transform s into t by applying the above operation or no. We can apply this operation as many times as we want. So is the problem making sense? Let me show it here also. So the problem here says that we have a string. We have a string s. We have a string t, and both of these are binary strings. So you will have only zeros and ones. You know, let's say you have something like 0010 11, and you have something like 001010 or something like this. Maybe you have um, this type of string. So what we want to do is we want to apply some operations on the string s and convert it into string t. And for converting the string s into t, there is a type of operation that we are allowed to do. In the operation, what we do is we choose two indices I and j such that si should be 1 and ti should also be 1, and we will just set both of these two. Sorry, not ti but sj. We chose two indices I and j, no? So si and sj should be 1. And what we can do is we can just set si and sj to be 0. This is the operation that we are allowed to do. And that's it. That's for the problem. So please tell me whether this problem is making sense or not. The constraints of n here are too small. I did not use this thing for my advantage in the solution though. I think my solution will work fine even if the strings are of Wiggleton. So shall we discuss the problem? Is the problem statement clear? Here in this case, the length of s and the length of t would be equal and it would be less than equal to 5. But my solution did not really have anything to do with the length being smaller than 5. My idea was if in the string s and in the string t, there are two equal characters, then I have nothing to do with these this index. Now let's say if on index 5, both of the characters are equal, then I should never try to make any changes on this index, right? This is one obvious thing that we should note. Nextly, obviously it is true if both of these are ones also. If let's say both of the characters are 1 at some index, then also we should not make any changes on those indices because they are already equal. So this is already good for us. Nextly, if there is some 0, let's say on index 10, there is a character 0 in the string s, and on the same index, the character is 1 in the string t. So I can never make s equal to t because if si is 0, I can never apply an operation on this character. है ना? The only operation that I have is to apply on some index which is equal to 1. the character should be equal to 1 and I can set it to 0. But if there is a character which is already set to be 0, I can never make it 1. So if I ever have a situation for some I, if Si is equal to 0 and Ti is equal to 1, then I can safely say then the answer is false. है ना? I can safely say that the answer would be false. Do you guys agree with it? Like, is it clear enough or do I need to explain more? Can you repeat the question again? Okay, let me repeat the question. The problem set, we have been given two strings S and T. Both of these strings are binary. That is, they will have only characters 0 or 1. We want to make this string S equal to string T. We have to transform it. And for transforming it, we are allowed to apply a type of operation as many times as we want. In the operation, what we can do is um, choose two indices I and j such that Si is 1 and Sj is 1 and set both of them equal to 0. Right. So that is the problem. We have to return either yes or no. We have to return either yes or no. If we can transform S into T or not. That's it. So AI Queen, oh, the name does not look good. So I hope your doubt is clear. Let me just confirm one thing. Yeah, we can apply the operation any number of times. Okay, so for the logic of this problem, what we have discussed is if at any index I, both Si and Ti are equal, if both of these are equal, then we don't really need to do anything. We can safely ignore them. If Si is 0 and Ti is 1, in that case, we cannot convert Si to 1 because the only operation that we have allows us to convert a character from 1 to 0. है ना? That will also happen only if we have two characters which are 1. Both of them would be converted to 0. Um, in any case, we can safely say that we can never convert a 0 into 1 by the operation that we are permitted to do. So if Si is 1, Si is 0 and Ti is 1, then we can safely return 0. Now, if let's say this thing does not happen, there is no such case of Si being 0 and Ti being 1. And there is a case where Si is 1 and Ti is 0. Then we can actually convert Si from being 0 to Si being 1. But that will happen only if we have some other index as well, which, sorry, from 1 to 0. Yeah, from 1 to 0. We can do this thing only if there is some more index that has to be converted from 1 to 0. So can I say that I will have even number of, like I can convert even number of indices. I can only convert even number of indices. In one operation, I will convert two occurrences of 1 to become 0 in Si. Let me take some examples for more clarity. If we have something like 111 and 010, S is 111 and T is 010. Then in this case, what we can do is we can choose these two indices and convert them to 0. Right? We can choose these two and convert them to 0. So we would be able to make S into T. So our answer should be yes in this case. We are right now discussing some examples. In the next example, let's say you have S equal to 1, 1, 1 and T equal to 0, 1, 1. Here you would not be able to convert S into T because you have only one occurrence of this 1 0 pair, basically a pair, basically an index which you want to convert from 1 to 0. You have only one such index and you need at least two indices. So if you choose this guy with this guy or something, then you will convert it into 0 and it will not match, you know. So basically, whatever you try to do, at the end of the day, you will realize that you can never make S into T if you have only one such index where you want to convert. So here the answer would be no. Let's take one more example. If you had S equal to 1 1 1 and T equal to 0 0 0. So in this case, there are three such positions which you want to convert from 1 to 0. But the problem is, in one operation, you will have to choose exactly two indices. So let's say you chose these two. Then you will have only one such index left, which is having the character 1 and you want to convert it into 0. So again, you are not able to convert S into T. So I hope you are able to notice what I wanted here to explain. The thing is, if the number of indices where you want to convert character from 1 to 0, if the in count of such indices is even, then in that case, our answer would be yes, else our answer would be no. Please tell me if this thing is making sense or not. Okay, great. Yeah, so our logic for solving this problem would be very simple. What we will do is we will iterate over the array. We will, sorry, not array, but string. We will iterate over this string s. And for every index I, we will compare si and ti. है Now, what can happen with si and ti are? There are four possibilities. Either both of these would be zeros, or both of these would be ones, or si would be 0 and ti would be 1, or si would be 1 and ti would be 0. These are the four possibilities that we can have. In these two possibilities, you don't need to do anything. In this case, when si is 0 and ti is 1, I can safely say that my answer is no. And in this case, where si is 1 and ti is 0, I will find the count of such indices. And let's say you got the count to be x. So if this count is even, then the answer would be yes. If this count comes out to be odd, then the answer would be no. So this is the whole idea for solving the problem. Let me show you the code. So the code might look a little complicated, so let me make it a little simple. Since this is the very first problem, I'm considering that mostly people who would be watching would be beginners. So this is why I'm trying to make it a little simpler. Let's say you have four ways simple now. Okay. Yep. So this is the code for solving the problem. What we are doing here is, for every test case, we are calling this function solve, and inside the function solve, what we are doing is, first of all, we are taking the inputs. After that, we have been iterating over the string by having a for loop over the variable I from 0 to n. In case if we find out a case where si is 0 and ti is 1, then we will simply return false, or not return false, but we will set the answer to false. Otherwise, we will just find out. Otherwise, if we are getting a combination where SI is 1 and TI is 0, then this is a kind of index that can be fixed by applying the operation. So we will try to just find out the count of such indices. In case if the count of indices turns out to be odd, in that case we will update the answer to false. Otherwise, answer will remain as it was earlier. In case if we had found out a pair like 0, 1, then the answer would have been false, otherwise true. And whatever the answer is, we are just printing it here. So the main idea is, in case if we found a pair like this, we are automatically setting the answer to false. Otherwise, once we have found the count of these pairs, 1, 0 pair, then on the basis of whether it is even or odd, the number of such indices is even or odd, we are setting the answer to be yes or no. So is it clear? Okay, so someone is asking me if I can give some tips to uh, how to solve this problem fast. Let me think for a minute. Um, One thing that I can do for now is tell you the way I approach this problem. In my case, I think it took me like 1 or 2 minutes for solving the problem, which is fairly fast. So maybe this helps you. So like when I read the problem, for now, what I'm doing is I'm telling you about my thought process. So the ones who are not interested in this can just skip to the next problem. So this is the thought process that I had. As soon as I read the problem, it is binary. I did focus on this part while reading, that we have uh, we have binary string, and we can convert two indices from 1 to 0. This is the next thing I did put focus on. So as soon as I read this operation that you choose two indices I and j and convert like such that I and j are both ones right now, and then you update them to 0. As soon as I read this thing, I did know that something like this would happen. You would have something to do with the number of indices where Si is equal to 1. If the number of such indices turns out to be even, then you can convert them, otherwise you can't. You know? So in my case, as soon as I read the problem, I knew this is gonna happen. And the next thing that I did think about was, since I want to convert Si, the string S into the string T, so I would have to make Si and Ti equal for all I. So there are four possibilities that we can have for these two um, strings. For every character, there are four possibilities that can be there. I did skip both of these as soon as I thought about them. I thought about this case that my operation is not allowing me to convert a 0 to 1. So I did figure out that, hey, this is one possible case where I will have to say no. And this is a case which I had already thought of, that I will just count the number of this kind of pairs and check if it is even or odd. So if you try to think of how you could have solved the problem first, the thing is we have only this much data that we had to process, which is something I believe mostly 5-star coders and above would have solved in like 2 minutes or so. So I hope it helps. Lots of cheaters in this contest. Yeah, cheating has been too much nowadays. I also don't find contests that much interesting anymore because there are too many cheaters, especially in lead code and code chef. Anyways, let's move on to the second problem. You guys can have like 2 minutes, try to read it and understand, and then I will start discussing it. Okay, so let's discuss this problem. The problem says that there are n people lined up in a queue. The people are numbered from 1 to n, but not necessarily in the order they are lined up. So what they want to say is there is a queue, like there is a line of, let's say, 7 people for now. For now, n is 7, and the people who would be in the queue are numbered from 1 to n, that is 7 in this case. But it is not mandatory that the numbers would be like this only. It is possible the numbers might be like this: 1, 2, 3, 4, 5, 6, 7. The n people might be in any order, and we have been told, unfortunately, some of them can't understand where the front of the queue is. So some people are looking towards the front of the queue, and some are looking towards the back of the queue. The ith person reports AI as the number of people ahead of him in the direction he is looking. So let's say if the 7 people you had were in this order, the first person standing here, second standing here, third standing here, fourth here, fifth here, sixth here, and seventh here. There can be any order. Now, some of these are looking towards the front. The front is on the left hand side, so some of them are looking towards the front, but some of these are complete idiots who are looking towards the right. Or maybe I should not use words like this, but yeah, some of these are looking towards the right, and all of these will tell you the number of people who are in the line in front of them. So for the guy like this first guy, there are 3 people in front of him. So he will say 3. For this second guy, there are like um 2 people in front of him. These 2 people. So he will say 2. The third guy is looking on the right hand side. There is only one guy in front of him. So he will say 1. The fourth guy will say 0. Fifth will also say 0. For the sixth guy, there are 4 people in front of him. For the fifth, no, for the seventh guy, there are I think 5 people in front of him. है So you would have this array of integers telling you how many people are in front of them, and obviously they will not give you the array in this order. They will actually give you array in this order. 3, 4, 5, 6, 7. Here the first character will tell you what is the number that the first person gave. The first person gave the number 3. So the number here would be 3. The second person had given the number 2, so 2 would be here. Third person had given the number 1. 4 and 5 gave 0. 6 gave 4 and 7 gave 5. So this would be the given array given to you. Now what you have to do is you have to tell us, like you have to tell um, number of possible arrangements of the people in the queue, um, such that, um, let's say this was the queue, and this is the array that has been created from this queue. Let's say that there is some function f which converts the queue into this array. So we have to tell the number of possible queues, actually, the number of possible different queues of the people, such that f of q is equal to a. Basically, let me take one example. Let me take a smaller example for now. If you had only three people here, one, two, three, one looking here, three looking here, and two looking here, the array that you would have got is gonna be equal to 0, 1, 0, 0. So one possible queue that can give you the array 1, 0, 0 is this. Another possible queue is one here looking like on this direction, let's say. And in this case, one is looking on the left. This queue will also give you the same array. Similarly, if you had 3, 1, 2, where these are looking like this will also give you the same answer, and so on. Um, oh, sorry, I made a mistake. We have to tell about the queue, not the directions. Um, like if you say 2, 1, 3 like this, then it would not be considered as a different queue because the order of people is the exact same. So it would be considered as the same queue. But in this case, there will be only two answers here, like 3, 1, 2 and 2, 1, 3. These are the two possible queues which you can have. Mm, Lots of three tiers. Was this problem too easy? Yeah, the problem is easy. The first two problems for this PCD are gonna be easy. The next one would be a little tricky. Not difficult, but tricky. Okay, so guys, is the problem clear? Or do I need to explain it again if in case at some point of time it got confusing? Let me recap the problem once, just in case if someone messed up at some place. Basically, the problem says that we have been given a queue. Sorry, there is a queue having people from number 1 to 7 or 1 to n. है ना? Some of these people are looking towards the front of the queue. Yeah, some of these are looking towards the front of the queue, whereas others are looking towards the back of the queue. And everyone tells the number of people who are in front of them. Like for one, the number of people in front of him were 3. For the second guy, the number of people in front of them were 2. For the third guy, even though he was at the second last position in the queue, but since he was looking towards the back of the queue, he saw only one guy in front of him in the queue. Like from his perspective, there is only one guy in front of him. For the fourth guy, there is nobody in front of him. Similarly, for the fifth guy, then for the sixth guy, there are 4 people in front of him, and for the seventh guy, there are 5 people in front of him. You know, now we have to tell what are the possible arrangements of the queues, like uh, how many different queues are there possible, which will have the same array A, which will at the end give you the same array A. And I took one example here. If you had an array like 1, 0, 0, then one possible answer for this would be 2, 1, 3. Another possible answer would be 3, 1, 2. In this case, 2 and 3 would be looking towards the left and right here also. Let me take one example from here also. If you had an array like 0, 0, if your array was 0, comma 0, then one possible queue is if you have 1, comma 2, like the first guy at the front and then the second guy, or if you had two and then one. In both of these cases, the people can look in the opposite directions to see no people in front of them. You know, these are two possible arrangements or two possible queues in which you will have the same array. Yeah, and another possible, like another 0, 1, 2. So in the example 0, 1, 2, one possible queue is 1, 2, 3, where the first guy is at the front, so he does not see anyone in front of him. Second guy sees one guy in the front of him. Whether he looks on the left or right, it doesn't matter. He will see just one guy in front of him. And for the third guy, he also sees two people in front of him. Another uh, queue can be 3, 2, 1, where one, like they also see just zero people in front of one, two sees only one guy in front of him, and three sees two people in front of him. So here also we have only two possible answers. If you try to create any other queue, you will realize either it would be the same as one of these, or you will not be able to have the same array in from the queue. Another example here that has been given in the problem is 1, 1, 2. This one is a little interesting and it will help us to realize on how to solve the problem. So in this example, we have to create a queue, like we have to find out the number of possible queues in which the first and second people are able to see exactly one guy in front of them, and the third guy is able to see exactly two people in front of him. Now the problem is the only position from which you can see exactly one person in front of you is this position. है ना? But there are two people who are claiming that they were able to see exactly one guy in front of him, and you cannot place both of these here. If you place at any other place, if you place any of these at one of these places, then they will either see zero people in front of them or they will see two people in front of them. So, in a nutshell, because of the um, contradiction between these two people, there is zero possible answer in this case. So, there exists no valid order. So, guys, this problem statement clear? And the examples? CodeChef example test cases are pretty bad. Um, I think the example test cases are good. Okay, by the way, the comments were made 6 minutes ago. So, guys, Aniket and AI Queen, can you please tell me if the problem is clear now or not? I'm waiting for your comments. Like, if the problem statement now is clear, understood. Okay. What about Aniket? And please tell me about the pace of the explanation also. Do you guys think the pace is going well, or you want me to go faster or slower? I feel the current pace should be good enough. Little bit okay. Maybe I can do one more recap for the problem B, problem statement once. Just 1 minute. Give me a minute just. Mm. Okay. Yeah, so let me just recap it once. We had not read the complete problem statement either. The problem says there are n people lined up in a queue. The people are numbered from 1 to n. Oops, what happened? Okay, so yeah, so there are n people lined up in a queue. The people are numbered from 1 to n, but not necessarily in the order they are lined up. Unfortunately, some of them, like some people don't remember. Some people are looking towards the front, some people are looking towards the back of the queue. Every person tells how many people he see in his direction. We had read till this point. Then we are wondering how many possible orders of people would be there in the queue. Two orders are said to be different if there is at least one such position, I, such that the ith person from the front of the queue is different. Basically, you see, two orders would be considered different if they are having at least one um, person at different positions. And since there can be too many orders, the answer might be too huge. We have to answer it modulo something. And zero if no such order exists. 0 1 1 0 can be a test case. Yeah, let me take the test case 0 1 0. If we have array 0 1 1 0, in this case, the guys 1 and 4 can be at the front and at the bottom, sorry, at the back, and 2 and 3 can be in the middle. Now, one possible arrangement is this. Another possible arrangement will have 1 and 4 at the opposite ways, at the opposite directions. 4 2 3 1. Similarly, whether we place 4 and 1 like this or like this, the arrangements of 2 and 3 are independent of the order in which 4 and 1 are coming. Do you guys notice this? What is the order of these two people, whether 4 is coming at the front or at the back, does not have any impact on whether 2 comes first or 3 comes first. So, as we have two possible arrangements of these two people, 1 and 4, since both of these um, want to see 0 people in one of the directions, either you can place 1 and 4 at like this, or you can place them like this. Similarly, for 2 and 3, either you can place them at the second and third positions, or you can place them at the third and second positions. So you will have four total permutations or four orders in which um, the condition is satisfied that um, one is seeing 0 people in his direction, 4 is seeing 0 people in his direction, 2 is seeing 1 people in his direction, and so on. So what I want you to notice here is, let's say if there have been 5 people in a queue and the first person says that he was able to see one guy in front of him, then there are only two such positions from where you can have this privilege to see exactly one guy in front of you, right? Does it, like, can I say there is a guarantee that if the first person is saying that he was able to see exactly one guy in front, one guy in front of him, then either one would be here or one would be here. Do you guys agree with this? Similarly, if the second person says he saw 0 people in front of him, then there are only two such positions where the second guy must have been, right? The second guy must have been either here or here. Do you guys agree with it? So if in a problem there are more than two people who are having the value 1, can I clearly say that there is no possible way, like there is no possible order such that there are three people who are able to be at a position that they see exactly one guy in front of him. Can I say this? If in the array that has been given to me, if the count of any I for like any index or basically for any position, let's say position X, is greater than 2, then the answer should be 0 for sure. Do you guys agree with it? Uh, yes. Okay. One guy is asking me for 0 1 0 also. So in 0 1 0 wala case, you will have um something like 1 and 3 here and 2 here, or 3 here, 2 here, and 1 here. I think I had covered this case of 0 1 0. Oh, I covered 0 to 0, 0 1 2. Okay. There is this one case that I wanted you people to note out. This is always gonna be true. If you have more than two people asking for exact one position, like having the same position being mentioned, then the answer is 0. Guys, I will be back in a minute. Just 1 minute. Okay, I'm back. Okay, next thing that I want you to notice is if somebody said, let's say a person once said, there is one guy in front of him, then obviously that guy must have been at one of these two places. Similarly, if someone, let's say the second guy said that he saw three people in front of him, then also there are these two exact these two positions only for which it is possible to see three people in front of you. Right. Like if you are here, you can see these three people. If you are here, you can see these three people. There are only these two positions. So do you guys agree that if somebody said one or if somebody said three, it is the exact same thing, whether AI is equal to some value x or if AI is equal to n minus x minus 1. Both of these would be the same positions. Do you guys agree with it? So in a nutshell, what I can say is the count of x plus count of n minus x minus 1, this thing should definitely be equal to 2. In case like unless this x is actually the middle guy. In all the other cases, if x is not the middle guy, for all of those indices, the count of x and count of n minus x minus 1 should be equal to 2 for sure. Do you guys agree with it? Because um, there must have been, like if you are talking about some order in which every position will have exactly one guy, so there must have been two people at these two positions. Now, doesn't matter whether this guy said three or did he say one. Did this guy say one or did this guy say three? At the end of the day, count of x plus count of n minus x minus 1 would have been equal to 2. है ना? Count of 1 and count of 3 would have been equal to 2. Right. And since we are able to think till this point, now we know that in case if for any position other than this, if for any of these positions you find out count of x plus count of n minus x minus 1 being anything not equal to 2, then the answer would be just straight away 0. Talking about the middle guy, if even else, like for the middle guy, there is only one position. If let's say n is 5, then the person for whom AI was equal to 2, that is nothing but n by 2, that guy must be placed at the middle. So if x is equal to n by 2 in case of odd sized array. Then count of x must be 1, right? And by the way, you don't really need to check for this condition, because if you're checking for all the other people, whether all the other these two positions are having exactly two people, these two positions also had exactly two people, then at the end of the day there would be exactly one guy left and exactly one position left. So even if you don't check for the middle guy, you will still get the same answer. And if you want to check for the middle guy, you can have this condition. Obviously, you need to add that n mod 2 must be equal to 1 also. You know, you can write the if else conditions by yourself. Now we have to talk about how will you find out the number of uh, possible orders. So the thing is, there will be exactly two people in possible order. There will be exactly two people who would have said something, either 0 or 4 in this case, such that you would have said that both of these should be placed at one of these places. Like if, if the guy 1 and 7 said 0 and 4, then you know that one of these will come at this position and the other guy will come at the other position. So there will be two possible arrangements for these two positions. Similarly, there will be two possible arrangements for these two positions and so on. For the middle guy, there is only one possible arrangement. है ना? Do you guys agree with it? Like, does it make sense that if you have an array and you have um, the number of people saying 0 and the number of people saying basically the number of people saying 0 plus the number of people saying um, n minus 1 are equal to 2. So you will have to place one of them at the first place and the other guy at the last place. So you are having two possibilities, like you are having two possible orders. है ना? If guy 1 and 7 had said 0 and n minus 1, either you could have placed them like this or like this, 1 and 7. है ना? So there are two possible orders for these two positions. Similarly, there will be two possible orderings for these two positions, two possible orderings for these two positions, two possible orderings for these two positions, and so on. So if there is an array of size n, then you will have n by 2 separate pairs of these two positions. है ना? Now, in the case if you had, like, let's say 7 elements, then you had got two positions here, two positions here, and two positions here. So the answer would have been 8, right? Because one possible arrangement will have 1 and 7 here, another possible arrangement will have 7 and 1. Similarly, you can have 2 and 6, or 6 and 2, or 3 and 5, or 5 and 3. है ना? So um, you will just have, like, your final answer for the problem would be nothing but 2 raised the power n by 2, where n is the size of the array. And we have to answer it mod 99835, whatever that prime number is, whatever that mod value is. So is it making sense? I tried to go like really slow in a really beginner friendly way. Have you done adjacent or? Um, I did try adjacent or, but my code did not work out. Like I got wrong answer and uh, I could not debug it during the contest. So I will do it after PCD. We will not discuss it in the PCD for now. The fifth problem. Okay, so guys, please tell me if you have any doubt in this problem in the logic part. Otherwise, we can move on to the code part. Why don't you check the middle element for odd size? If you want, you can check it. It would not affect you even if you don't check, because um, you see in the array having, oh, this one's array. Yeah, if an array is, let's say, having 7 guys, you have checked for the three first positions, first three positions and last three positions. So you have only one option left for the middle guy. He must be equal to the middle position only, because if he was not equal to the middle position, he must have been equal to some other position, and then you would have um got this condition failed. Yeah, this condition would have failed. So even if you don't check for the middle guy, the answer would still be the same. But if you want, you can check it. Like if you um, did not understand why it would definitely be correct. Your voice is not coming. Is it coming good now? Why don't we check the middle guy, and why do we check for AI plus equal to equal? Specifically two. Okay, so um, as we discussed earlier, if let's say some guy had said that he could see three people in front of him, either he would be looking towards the left direction. Sorry, not three. Let's pick up another example. Let's say pick two. Let's say someone saw two people in front of him. So either he would be looking towards the front. So if he was looking towards the front, then he must have been at this position. Or he would be looking at the back direction. He must have been looking towards the back. So in that case, he must have been at this position, right? Either he would be here or he would be here. So there are only two positions where the person can be. You know? And in these two positions, you see, there should be exactly two people. There should be exactly two people who are at these two positions, because at every position a person exists, right? So um, there will be two people exactly. One of them, now depending upon whether they are looking towards the left or right, they will either say two or the other number, that is the remaining people on the right. You see, there are two people on the left, let's say X number of people on the left. One of them, and the one position is occupied the person who is standing and looking towards that direction. So the number of people on the other direction must be n minus this x minus 1. है ना? So that is why we are checking whether the count of x plus count of n minus x minus 1 is equal to 2 or not. Why is it specifically 2? Because we want exactly two people. We have exactly two positions, so we want exactly two people. For the middle position, we have exactly one position here. है ना? We have exactly one position in the queue where there can be a guy who is in the exact middle. So we want the count of this thing to be exactly 1. Kavish, is that doubt clear now? I hope it would be clear. So, if you have any doubt, you can ask. And in the meantime, I will start explaining the code. Oh my God, this is not working. Okay. Anyways, I can't zoom in for some reason. Let me remove the unnecessary code. Okay, so for every test case, I have been running a function named solve. This is a lambda function that I've created. Like as you create a function here and solve something, similarly, you can create a function inside a function also, as I've created here a function. And the benefit of creating the function here is that if I want to create something that is common for all the test cases, then in general, you are forced to create a global variable. है ना? But in case if you are creating the function like this, you can just create those variables here itself. And here you can write out the code for the pre-computation as well. So I don't have to scroll up and down too many times, and it makes things a lot easier for me if I'm writing code like this. like if I'm creating the function here. Nextly, let me explain the function here. I will take the inputs first, and I'm keeping track of the count of every number here, frequency of every number here. And since we had to return the answer modulo something, I created a variable with name mod and did put up the value there. It can protect you from sometime making some typo. If you are writing the exact number every time, then you might sometimes make a typo, typing error. And it looks a lot cleaner if you use the word mod instead of the number. Nextly, I have an answer variable. I'm iterating over um, a range of values from I equal to 0 till I is less than n by 2. So basically, I am iterating, like I'm having a for loop of I from this position till this position, which is stopping just below, just before the middle element. If there are even number of elements, let's say if there were only 6 elements, then I would have iterated 6. If there are 7, then I will, sorry, if there were 6, then I would have iterated only 3. If there are 7, then I will iterate only 3 and leave the middle guy. And here I'm checking if the count of I plus count of n minus I minus 1 is not equal to 2. If it is not equal to 2, then return 0 because there is no valid ordering in that case. Otherwise, answer will just become double. So either you can write it like this for finding 2 raised to the power n by 2 mod, or you can just use a power function. You will see a lot of people having function with name something like power. Like if you guys know about binomial exponentiation, you could have used that also, but it's not really required. You can just run a for loop of size n by 2 or something, as I have done here. Here, this is a for loop of size n by 2, where I am doubling my answer again and again to find out 2 raised to the power n by 2. So in a nutshell, either I will return 0 because of this if condition failing somewhere, or I will return answer that would be equal to 2 raised to the power n by 2. One of these things will happen. One of these two things. Okay, so Kavish was also clear with the doubt. I hope the code would also be clean enough. That's not too messy. So let's move on to the next problem. It's 11:30. Okay, I need to go a little fast now. For the first two problems, I really did go very, very slow. So that each and every person who is watching the PCT can understand. Now for the next two problems, I will be a little fast because we need to keep the PCDs with some good enough length also. No, we can't extend it for like 3 hours or something. So this is the third problem, double or append. The problem says we have been given an integer array A with size 0. We have to handle M operations of type 2. Sorry, two types. The first type is let X be the MEX of A and replace A with X plus A. Basically, append or prepend. Yeah, prepend the MEX of the array into the array. The type 2 operation is replace A with A plus A. So what we have to do here is we have been given um, yeah, we have been given an integer array with size 1 initially. There is an array A which is having only one element that is equal to 1, so that is equal to 0. And we will have M operations. In each operation, you will have uh, one of the two things. You will have to do one of the two things. The type 1 operation says whatever the array is, find out the MEX of the array. MEX is the minimum X, the smallest non-negative integer that is not in the array. So like if you had an array like 21045 1, something like this. Here, the smallest non-negative integer that is absent is 3. 3 is the smallest absent non-negative integer. So MEX would be 3. So similarly, we will have to find out the MEX of the array and we will have to append it. So if X is the MEX, put it at the beginning of the array. So as an example, if array A looked like 2140, let's say only this much, the MEX here would be 3. So what will happen is array A will become 32140 if you add this kind of stuff. Nextly, we have the type 2 operation. In the type 2 operation, we just have to update array A into A plus A. So if the array A looked like 1021, then the array A will become 1021 1021. This is gonna happen with the array A. Yep. And what we have to do is after after each operation that we apply, we have to find out the number of inversions in the array A. And it is guaranteed that the size of the array A will never exceed 10 raised to the power 9. So what is number of inversions? We have to count. We have to count the number of inversions in the array, and the number of inversions in the array is nothing but number of pairs, like uh, number of pairs of indices I comma j, such that I is less than j but ai is greater than aj. So the pairs here like 2 1 or 2 0 or 1 0 or 4 0, these are inversions. 1 0 here, 2 1 here, 1 or 1 0 or 2 1 or 2 1 or 2 1 or 2 0. All these are inversions. So is the problem clear, guys? Someone is saying that Bhaiya, you should go slower for the higher problems than initial ones. There is a reason why I'm going a little fast. Like I'm not going a little fast right now, but I want to go fast for the higher problems because the ones who would be attempting their more difficult problems should be skilled more. You know, if someone is coming up to the, like, let's say the fourth problem, then I expect that he would be at least a 5-star coder because um, if I explain um, like I teach and every step and it becomes more like spoon feeding, then it would not really help you much for the difficult problems because you will not really, how can I explain? It's more like you should put up more efforts for the more difficult problems. Anyways, any problem for this? Any doubts in this problem? But if someone wants to update his level, for improving your level, you will have to put up more efforts by yourself. Um, Even if you solve a problem by watching some editorial, which you can't solve by yourself, it would not really help you much because when you will get the same problem in a contest or similar problem in a contest, you won't be able to solve it. You can watch it 0.75. By going fast, I'm not talking about speaking fast. By going fast, I mean that I will skip a lot of things. I will skip the easy parts. Okay, so the problem is done. Now, see, we have only two things. All we want to do is we just want to keep track of the number of inversions, and we will have to apply these two operations. है ना? The array size can actually become too big. So one thing that should be obvious is you cannot really maintain a complete array. Initially, the array might be just 0, but when you apply a type 2 operation, the array size become 2, then the array size become 4, then 8, and so on. Whenever you apply a type 2 operation, the size of the array will just become twice as big. So in a nutshell, we cannot apply, we cannot keep track of the array. Right. Nextly, we don't even have to do anything with the array. At the end of the day, our answer is gonna be the count of inversions. We will have to tell what is the number of inversions in the array. So let's try to think, like you should try to think about um, keeping track of only those things that are required for finding the number of inversions. You know, like we will have to figure out what information we need to keep track of so that we are able to find the number of inversions. So initially the array would be 0. So the MEX of the array should definitely be 1. Now, when you apply, like if you apply the type 1 operation, then the array will become 1, 0. है ना? You would add the MEX at the front of the array and now the MEX will become 2. Now, one thing to notice here is um, type 1 operation increases the MEX by 1. Whichever character is the smallest non-negative character not in the array right now would be inserted at the front of the array whenever you apply the type 1 operation, and the MEX will now become one bigger number because 1 is now present in the array, so MEX will become 2, right? If you apply another type 1 operation, then MEX will become 3 and so on. Whereas if you apply the type 2 operation, then you are just putting up all those elements that were present earlier. Like if you have the array 1, 0 and you apply the type 2 operation, then the elements would just repeat themselves. So the MEX will not be changed. है ना? In the type 2 operation, MEX will remain the same, right? So this is one thing that I wanted you to notice. Nextly, since we have something to do with inversions, let's try to find out what would be the impact of type 1 operation and type 2 operation on inversions. So whatever array I had, whatever array A I had, when I applied type 1 operation, the MEX got added at the beginning of the array, right? Now it became like this. The MEX has been inserted at the front of the array. Do you guys agree that this must be the largest element of the array? Because the only way in which we are having a bigger element added is by type 1 operation. And whenever we apply the type 1 operation, the MEX that is being added is always the biggest guy. Here it is going to be the biggest guy. If you apply type 1 operation on this array, then it will become 2, 1, 0, 1, 0. Again, you will have the biggest element being inserted. So the claim here is X will be the biggest element in the new array, right? So if the previous size of the array A was, let's say, SZ. This is the number of people, like the count of all of these people is, let's say, SZ. Then the number of inversions in the array should be incremented by SZ. Right? Do you guys agree with it? Whatever was the number of inversions earlier, whatever is the number of inversions for these people, all those inversions will still remain there, but there will be many new inversions added because of this X and these people. All of the people here are smaller than X. So the number of inversions, the number of new inversion pairs should be increased by SZ. Right. This is what happens in type 1 operation. Now what happens in type 2 operation is your new array is nothing but the repetition of itself. So whatever array A was here, it got just the same copy of itself again and being attached one by one. So if the array was like 1010, now it got 10101010, basically happening a lot of times. So um, yep. In this case, the number of inversions, like let's see what will happen with the number of inversions. Do you guys agree? Whatever was the number of inversions here in this array, the previous array before the operation that we applied, the same number of inversions would be there in the replica that you have created of the array, right? So the inversions between these people and the inversions between these people would be same, and they would be equal to the previous value of inversions. So 2 into, like, let's say new inversions, new count of inversions is equal to 2 into the number of inversions that we had earlier, plus there will be some more inversions like this. One from this, like you pick up one element from the left array and one element, or like you pick up one element from left array and one element from right array. है ना? So the number of inversions that you will have in this case is, for every element of this array, if I just find out the number of people who are smaller than this guy on the right hand side, basically for the guy with the value 1, if I just find out the number of people with the value 0, can I say that this many new inversion pairs would be increased? है ना? So what I can say is, um, count of I, like for each value I from 0 till x minus 1, we will just want to find out the count of j, which is smaller than I. I wrote an expression. Let me explain this. This is the expression that I got while solving the problem. That for every element, you just want to find out the number of people in this array which are smaller than the element here. है We are picking one element from left array. We are picking one element from the right array. If you are confused of what about the inversions which are happening with both elements from right array or both elements from left array, we have already considered it because we already know about the number of inversions of this array. So that thing was just happening twice. Now we only need to care about the inversions where one element is picked up from this array and one other element picked up from this array. So can I say that since one is coming two times in this array, or whatever is the number of inversions you have of this guy with some elements from this array, the same inversions will happen with this guy. First of all, guys, please tell me, were you guys with me till this point at least? till this part where we had discussed about type 1 operation? Were you guys able to understand till that point at least? Okay. Is there anyone okay? Is there anyone who got confused at any place um before this point? And if you have any doubt, then you can ask. Talking about the type 2 operation, what is happening is you have got two replicas of the previous array that you had, and we know we would have calculated the number of inversions in this array, है ना, before the operation. And after the operation, we got just this array coming one after the another. If you had array elements like 1010, now you have 1010 1010. So my idea is either you will have inversions between elements like either the I comma j pair, which form an inversion if ai is greater than aj and I is less than j, whether both I and j will lie in the first array or both of them will lie in the second array, or one of them or I will lie in the left array and j will lie in the right array. And one of these three things will happen if you have an inversion pair I comma j. So for all the inversion pairs within this array, you must have calculated this thing when you would have formed this array. Like right now, when we are forming this bigger array, we are calculating the number of inversions for this array. So we must have found the number of inversions for this array when we would have formed this. So if we have stored it inside some variable with name inversions, you can say the number of inversions here plus the number of inversions here is nothing but 2 into the number of inversions. Nextly, we have to calculate the number of inversions where one element is picked up from here and another one element is picked up from here. For this, there is a very simple way. You can just say iterate over all of these elements one by one. And for each of these elements, let's say if I is here, the index I is here, then you will iterate over this second half, this second replica of the array and find out the number of people who are smaller than um, AI here, right? You will just find out the number of indices j where aj is smaller than ai. Obviously j is always going to be bigger than I because you are talking about all the indices where j is on the right. Now this is one way for um, finding out the new number of inversions, but the problem is we can't really store the complete array. This is the first problem. um, and the second problem is even if you could store it, it would be very inefficient. You will have to go of n square time complexity if n is the size of the first half. You know, to optimize it, what you can say is um, the thing that you can say is just keep track of the frequency of each of the characters. If you just keep track of the frequency of all of the characters of the array, then you know that whenever you're applying the type 2 operation, basically if you are keeping track of the maybe you just iterate over this array and find out the count of basically frequency of every element. Let's say count of x tells us the frequency of x in the older array. By saying older array A, I mean the array A before applying the operation. Before applying the operation, the array A was this, and after applying the operation, the new array is this. So let's say I figure out this count of x, keep track of it. Then a more optimal solution can be something like for each I, um, yeah, for each I belonging in the range from 0 till x minus 1, um, just find out for each j in the range from 0 till I minus 1. Answer, or basically the number of inversions, should be increased by count of I into count of j. So guys, please tell me if this thing is making sense now. The way in which we are calculating the number of inversions, that the number of new inversions that would be formed. If we know about the frequency of all the characters already for the array that we would have formed, then while applying the type 2 operation, we can iterate over, like we can go for all the integers from 0 to x minus 1. And for that, we can just find out the number of total integers that would be smaller than the guy I, and we can insert it in this way. So basically, this thing is pretty much like saying, find out the number of 1 comma 0 inversions where 1 is being picked up from this left half and 0 is being picked up from the right half. है ना? We are in counting the 1-0 inversion pairs like that. So here the time complexity is big O of x square, which is definitely better than big O of um, n, in case n the like this is definitely better than big O of n, because n is the size of the array, whereas x is the MEX of the array, the max, the smallest element that is missing in the array, right? The smallest non-negative integer that is missing. The thing is, n can grow exponentially. Whenever you apply the type 2 operation, n can go from 1 to 2, like from 1 to 2, then 2 to 4, then 4 to 8, then 8 to 16, and so on. Whereas x will increase only when you apply the type 1 operation. It would start from 1, then it will go to 2, 3, 4, 5, and so on. So let's say if you applied 1000 type 1 operations, and then you applied a type 2 operation, then you will have to go over 1000 elements only. And you will have only 1000 integers to consider, which is way better than the case if you had, let's say, applied 10 type 2 operations. The array size would have already reached 1000, and then you apply type 2 operation again. So even with just 11 type 2 operations, this big of n square time complexity would have been worse in comparison to this, having multiple type 1 operations than a type 2 operation. So guys, please confirm if this thing is making sense or not, of why this approach is better than the previous, the brute force approach. I'm removing your contest comment because of the word that you used. If you want, you can write the same comment again. I don't have any problem with the comment, but uh, it was just having a word that should not be used, so that's why I removed it. Big of 1 में पता चलना चाहिए. I don't think it will work in big of 1. Log of 29 into n होता भाई. Type 2 operation तो n square हो गया. Yeah, type 2 operation was going into big of n square if we were thinking with a brute force method. Now we have thought about a more optimized method, which is working in big of x square. Now it might look like this is still gonna give a TLE. है ना? Right now you might think that, hey, we have around 2 into 10 raised to the power 5 operations in total, right? So what if we have 10 raised to the power 5 type 1 operations, and then we have another 10 raised to the power 5 type 2 operations? So what will happen in this case if we have this kind of stuff? After the 10 raised to the power 5 type 1 operations, the value of x will become somewhat like 10 raised to the power 5 or so. So if you have 10 raised to the power 5 type 2 operations where you are having big of x square time complexity every time, you will just get a TLE. By the way, x square is actually bad. We have to optimize it further. Um, how can we optimize it? Yeah, we can optimize it. We can merge the two for loops to just work in big of x. We will discuss about it later on. In my solution, I had done it in big of x. So for now, let's talk about big of x time. Like optimizing it is not difficult. It is very simple. For let's say I equal to 5 right now, you would be iterating for j from 0 to 4, है ना? And then for I equal to 6, you will again iterate from j equal to 0 to 5. So instead of iterating from 0 to 5 again, you can store the result of the previous iteration from j equal to 0 to 4 and just um, add for the case when j is 5. You can do something like this um, to reduce the number of inversions or no. We will see. Right now, I'm focused more on something else. But it was something like this. It was a trivial optimization that I had made to make it do it in big of X, and I believe you guys can also do it. Okay. So for now, the thing is, it might look like you will have a time complexity of 10 raised to the power 5 into 10 raised to the power 5 iterations, and it will give a TLE. Would you guys like to guess why will we actually not get a TLE? Let me give you a hint. You cannot have this many type 2 operations. We had a condition that the size of the array would always remain less than equal to 10 raised to the power 9. So, and we know one more thing. Whenever we apply a type 2 operation, the size of the array doubles. So, the number of type 2 operations that you apply cannot even be equal to 30. You know, they have to be less than 30. Because even if your initial size of the array is 1 and you only apply type 2 operations, in 30 operations, the size will exceed 10 raised to the power 9. So you will have a limited number of type 2 operations. That is why the actual time complexity would be better for a specific test case. So for a specific test case, the worst time complexity that you can get is, let's say you apply X number of type 1 operations, which all work in big of 1 because all we are doing for the type 1 operation is just increase the number of inversions and um, increase the size also, right? That's all we are doing. So, and yeah, we do set count of x to be 1 also because we have got a one new element. So that's all we are doing. So the time complexity for these operations would be just big of 1. Nextly, we can do like at most 30, not even 30 type 2 operations. You know, let's say 30 type 2 operations. So you will have big of x time complexity for all of these. So after having x plus 30 number of operations in total, your time complexity is coming out to be 30x, right? Not even, yeah, somewhat like 30x plus x, you can say like 31x or whatever you want to say. It's around 30x or so. And m is not too huge, right? So even something like this happens, even if something like this happens that you have 100 test cases or maybe more test cases or whatever. In the first test case, you have X test cases of type 1, then you have few type 2 test cases, then you have some type 1. In the next test case, you have some type 1 operations, then some type 2 operations. Then in the next test case, you have some type 1 operations, then type 2 operation, and so on. Um, overall the sum of m over all of these test cases would not exceed 2 into 10 raised to the power 5. And you know that for every test case, you are having the time complexity of something like 30x. So the sum of 30x over all test cases um, will not exceed 30m, है ना? Or basically, you can say 30 into 10, 30 into 2 into 10 raised to the power 5, which is like 60 into 10 raised to the power 5, or you can say 6 into 10 raised to the power 6, something like this, which is actually not so bad. It's actually a pretty good time complexity. Generally, we expect something better than 10 raised to the power 8. So even something like 10 raised to the power 7 or 2 into 10 raised to the power 7 is good. So 6 into 10 raised to the power 6 is completely safe. Right. So that is why I had said the problem is a little tricky, because it might seem like you will get a TLE with this kind of an approach, but um, if you do the time complexity analysis properly, you will realize that hey, it will never give you a TLE. So that was the main part for solving the problem, main observational part, that you cannot have more than 30 um, type 2 operations. So guys, is it making sense? कब कौन सा ऑपरेशन यूज करना है कहीं मेंशन ही नहीं है हमें नहीं oh, I think this is not clear. Like, we would be told which operation we have to apply. We will just have to tell what is gonna be the new number of operations. We have to apply the number of, we don't have to apply the operations by ourselves. Here I was just talking about what is the worst case that can happen for us. The case where we will have the worst time complexity. Because for every type 2 operation, we are having big of x time complexity. So obviously the worst case will happen when you apply all the type 1 operations first and then the type 2 operations. That is when you will have the worst time complexity. So I was just discussing about the time complexity for now. You don't have to worry about which operation to apply when. Oh, Akshay, you actually pointed out the exact same thing that I was willing to point out. Um, I just thought that initially I should discuss with the mistake that someone might assume we can have 10 into 10 is the power 5 type 2 operations. Log कहाँ से आ रहा है इधर? Very very size double is okay. Amit, is it clear now or not? Okay, got it now. Great. Okay. Size double हो जाएगा ना, ऐसे log आ रहा है, if you assume all the type of functions, this trail is only so yep. Type 2 operation would not increase the size. Yes, the type 2 operation will not increase the size of this count variable, like this count vector that we have been creating. When we apply a type 2 operation, the array size n will become double, but the count size will just remain the same. And when we apply the type 1 operation, both of these increases by 1. Okay, so this is pretty easy now. Now all we need to do is um, just simulate this thing. Applying the type 1 operation, like for the code part, implementing it would be very, very simple. You just have to do these three things. Increase the number of inversions, increase the size of the array. We will keep track of the size because it is required for knowing about how much the number of inversions will increase. So we will keep track of it also. And we need to know about the count of all the variables. That is why we have introduced this thing also. We will keep track of this. Nextly, for the type 2 operation, all we need to do is apply this equation. The new number of inversions would be nothing but 2 into the previous number of inversions. Nextly, we have this thing that for every I, we want to increase the number of inversions by count I multiplied with sum of count j where j is smaller than I. है ना? So what we can do is, let me explain this part as well since we had skipped it earlier. So if you have, let's say, the frequencies of elements as 1, 2, 3, 1, 2, 3, or whatever, these are, let's say, the frequencies of elements, and you want to find out, these are the frequencies of elements 0, 1, 2, 3, 4, 5. So you want to find out the sum of count of I multiplied with sum of count of j where j is smaller than I goes from 0 to x minus 1. So one way of doing this is just run for loops at the places of these sigmas. है ना? Your initially I is here, then when I becomes here, you run j from here to here. When I is here, then you run the loop of j over all of these elements. When I is here, you run the loop of j over all these elements, and so on. Another thing is, as you keep on moving towards the right side with your for loop of I, just keep track of the sum of all elements on the left. है ना? Have a variable, let's say, with named count smaller, which is initially 0. And when you move your I from here to here, increase the count smaller by the value. This is the thing that we can do for doing it in the linear time complexity. So it would be done in big of x time complexity. And I hope this is clear. Shall we discuss the code? If anybody has any doubt, then please mention. Till then, I'm making the code a little cleaner. Okay, there is one more thing that I forgot to mention. Um, Here we are updating the value of inversions, and you see the array has also got doubled. So you need to update the other variables also, like the size of the array should be doubled, and for like the count of I should also be doubled for all I from 0 till x. है ना? You need to update the frequencies and the size of the array also. Baki, everything that we discussed about the logic part is the same. And I don't see any doubts. So let's discuss the logic. Sorry, let's discuss the code. For every test case, I'm taking the number of operations as input. Instead of using the word m, I use the word q. It's up to you, whatever name you give to the variable. I'm having these three things, these three variables used for storing all the information I need: a count variable, size of the array, and answer. The frequency of any element or the size of the array will never exceed 10 raised to the power 9. So these things can be taken in int. The answer can be very big. If there is an array of size 1e9, then there can be around 10 raised to the power 18 iterations. Sorry, 10 raised to the power 18 inversions. So I have kept long here. For every operation, I take input the type of the operation. If the type is 1, then just insert a new element with frequency 1. Basically, the new value of x. Insert the MEX with frequency 1. The answer will increase by SZ, that is the size of the array right now, and the size of the array will increase by 1. For the type 2 operations, you see the number of inversions had to be doubled first. You had to double the number of inversions like this here. The number of inversions would be doubled. After that, I'm running a for loop of I from 0 to count of size less than count of size. Basically, the count of size would be equal to the MEX value. It is just I preferred to not create a new variable with name X or MEX and just use the vector size. If you want to even create another variable in X equal to 0 here, sorry, 1 here, and X increased every time, or you can just keep on like the way I'm preferring right now. Answer would be increased by count of I into count of smaller, and count of smaller would be increased by count of I. And later on, once you are done with updating the answer, I'm updating the frequency of all characters, and I'm updating the size of the array also. So that's it. After every operation that I apply here, I will print the answer, and then I will just keep on doing it for all the operations that I had to perform. So that's it. Well, even if size is 9, then linear time complexity might also not work. Our linear time complexity is not depend like the size of n might become as big as 1e9, but my time complexity is actually equal to big O of 30x. It is dependent upon x and not n. X, and you see this, we have actually calculated that big O of 30x can be at most 6 into 10 raised to the power 6 or something. Because uh, even if all the test cases that you have are having 30 type 2 operations and XX number of type 1 operations, um, even in the worst possible case, you cannot have more than 2 into 10 raised to the power 5 operations in total. And for every test case, even if you applied X number of operations and you got only um, 30 into X as the time complexity for X operations, like for X operations, you got 30 into X as the time complexity. Overall, you can have at most M number of operations. So the overall time complexity would be 30 into M in the worst possible case. And M can be as large as 10, 2 into 10 is the power 5. So worst possible time complexity is this. I believe you did mistake. You got mistaken in between these two things. We are having linear time complexity of this X and not N. Sir, can you please explain about inversions type 2, especially what is happening in the first loop? You are talking about this. So what I'm doing here is, as we did discuss, one possible way of coding this for now is, one possible way was, you could have just coded it in this way. For each I in the range from 0 to x minus 1, and for each j in the range from 0 to I minus 1, inversions would be increased by count of I into count of j. You could have done something like this, right? Basically, here you are finding the number of I comma j pairs where I is lying in the first half and j is lying in the second half, and I is greater than j. So this is definitely an inversion. And it was taking big of x square time complexity. A better solution here was that if for some I, you are already calculating the sum of all j um, less than I, then for the next value of I, you are again calculating all of this. Um, like you can avoid all of this if you just keep track of the sum till now in a variable. You know, you can have something like a variable count smaller. So you can do something like for I will go from 0 to n minus 1. For j, that will go from 0 to I minus 1. Earlier, you had been saying something like count smaller is 0. You say count smaller would be increased by count of j, and then at the end you can say answer should be increased by count of I multiplied with count of smaller. Right? That is what this equation was now. Count of I into the count of people who are smaller than this, smaller than I. This is what we are saying. So instead of having this loop again and again, complete for loop, you can just declare this variable outside and keep on upgrading it um, every time you go from I to I plus 1. Venkata, is it making sense or not? And what about the other people? By the way, how many people are there in the live stream right now? I don't think I can see it on my screen right now. Clear. Okay, great. We have discussed the code, so let's move on to the next problem. The final problem of the PCD for now. And this is actually going to be a little more difficult problem than the previous problems. Even if you go to the standings to see the number of submissions, the number of submissions for this problem decreased significantly. There was a significant drop in the number of submissions. So on my hand, I do recommend people who are like 5-star coders or at least high 4-star coders. Like I would be imagining that I'm explaining this to these people. We define SMEX value of a sequence as the second smallest negative integer that does not appear in the array. So as we guys know, MEX is the smallest non-negative integer missing in the array. In case of SMEX, they say that this is the second smallest. Okay. Second smallest non-negative integer that is missing in the array. I hope understanding what is SMEX should not be difficult. We have been given an array A. We have to calculate the sum of SMEX values over all the 2 raised to the power n minus 1 non-empty subsequences of A. Since the answer may be very large, output it modulo something. So what it says is, let's take an example. Let's take this example 0, 1. Let's understand it with the help of an example. By the way, the goal here is to find sum of SMEX of all non-empty subsequences in the array A. This is the task that we have to perform. As an example, let's say if the array A is something like 0, 1, then there will be 3 subsequences, 0 or 1 or 0, 1. Right. The SMEX of the first subsequence would be 2. Right? Because 1 is the first non-negative element that is missing, then 2 is the second non-negative element that is missing. The SMEX of this array would be 2. The SMEX of this subarray would be 3. Right? So the sum of all the SMEX of all the subarray subsequences would be 7. I hope it is clear, like what we have to do. Let me take one more example for now. 3120. Okay, so if the array is 3120, then the number of like the subsequences that we have here are 3, 1, 2, 0, 3, 1, 3, 2, 3, 0, then 1, 2, 1, 0, 2, 0, and then there are subsequences, like there are a few more subsequences. It's gonna be troublesome. Like there will be like 15 subsequences in total. And for every subsequence, you will just find out what is the SMEX. Here the SMEX is 1. Here the SMEX will turn out to be 2. Here it will turn out to be 2 because no, it will turn out to be 1. Here it will turn out to be 2. Here it will turn out to be again 2. Here it is 1. Here it is 2 and so on. You can just find it out. Hai na? Because here you have 0 and 1 as the first two missing people. Here 0 and 2 are the first two missing people. Here 0 and 1 are the first two missing people. Here you have 1 and 2 are the missing people and so on. You will just have to take the sum of all of them. And whatever you got as the sum, that is your answer. So let me tell you about the idea that I had right after reading the problem. We have to find out the sum of, yep. What I did is I did the problem simplification thing. Or basically consider a subproblem. Consider an easier problem in which you have to find out the sum of MEX over all subsequences. Right. Finding this thing out would be comparatively easier than finding the sum of SMEX over all subsequences. So for finding the MEX of all subsequences, the idea is pretty simple. For every X, like whenever you have a deal like this, find the sum of MEX over all subsequences or find out the sum of MEX over all subarrays. Instead of going over all subarrays or subsequences and then finding their MEX, a better technique is find out the number of subsequences which are having all characters from 0 to x minus 1. Do this thing for all x. So basically for each x, find the number of subsequences such that 0 to x minus 1 are present, but x is not. है ना? Let me tell you one more thing. Like this is one way for finding out the sum of MEX over all subsequences. What you can do is just define a variable answer equal to 0 initially. Here, let's say this thing is defined by the is denoted by a variable count. So you can say answer equal to, or basically answer should be incremented by count into x. है ना? This is how you can find out the sum of MEX over all subsequences. There is one more way in which you can do it. Let's say the way is you add a condition or basically you find out the number of subsequences such that all integers from 0 to x minus 1 should come at least once in that subsequence. You don't add this condition and you just increment the answer by count instead of count plus count into x. So this is another way in which you can manipulate the problem of finding the sum of MEX over all subsequences. The only changes I have done is remove this condition and remove this multiply by x. So what will happen is if a subsequence is having all characters 0, 1, 2, 3, then this subsequence would be considered for x equal to 0, 2. x equal to 1, x equal to 2, x equal to 3. It would be considered for all of these x's. है ना? Sorry, it would be from 0 to x. Yeah. So basically, adding, instead of considering the subsequence only once for x equal to 4 and adding 4 into the answer, we would be adding 1, 1, 1 4 times. Yeah. So I just thought that it is good to tell you about one more good way of manipulating the problem. है ना? I have actually seen a problem in which we did manipulate the part of finding sum of MEX over all subarrays with the same way as I have told you right now. It was a very complicated problem which was solvable in that way, but was very difficult or actually unsolvable with the current way that we have been discussing. Okay, so are you guys with me till now? Regarding the part of this thing that we will do, sum of MEX would be nothing but for each x, we will go find out the number of subsequences which are having all elements from 0 to x minus 1 at least once in the subsequence. X should not be present. We will increment the answer by count into x. So let me take an example. If you have an array like 0, 0, 1, 1, 1, 2, 3, or maybe, yeah, 2, 3, 4, and x is equal to 2 right now, then what will happen is the number of ways or the number of subsequences in which you are having all characters from 0 to x minus 1 can be said as find the number of ways in which you can pick up at least 1 0, pick up, find the number of ways in which you pick up at least 1 1, at least one of these. And for these people who are greater than 2, like for 2 you have only one choice, that is don't pick it up. For the people who are greater than 2, you are having two choices, either pick it or don't pick it, है ना? And for the people who are smaller than 2, you have to find out the number of ways in which you can pick them up, at least pick up one of them. So the number of ways of picking up at least one of these zeros is 3. There are 3 ways. Either you pick up both of these, or you pick up only this, or you pick up only this. For these 3 occurrences of ones, there are 7 ways in which you pick up at least one occurrence of these ones. Either you can pick up only this, or only this, or pick up these two, or pick up these two, maybe like pick up these two, or pick up these two, or pick up all 3 of these. Or in other words, you can just say for 3 people, you are having 2 raised to the power 3 choices. है ना? For everyone, you have two choices whether you pick them up or not. And out of these 2 into like 2 raised to the power 3 possibilities, there will be a possibility where you don't pick up any of them. So 2 raised to the power 3 minus 1 will be the number of ways in which you pick up at least one occurrence of 1. So for some I, if you know the number of times that I is coming, you can find out the number of ways in which you pick up at least one occurrence of that I as 2 raised to the power count I minus 1. Okay. So the number of subsequences where x would be the MEX would be nothing but product of all, like the product of 2 raised to the power count of I minus 1 for all I from 0 to x minus 1 multiplied with 2 raised to the power count of greater. है ना? Where this count of greater is actually telling you the number of elements that are greater than 2. है ना? Because for all the elements that are greater than 2, it doesn't matter which element comes and which element does not come in the subsequence. So you will be having all those um, different ways for forming the subsequence because of them as well. Right? Is it making sense? I think everyone has left. It's already pretty late in the night also. Okay. So this is the number of uh, ways, or you can say the count of subsequences such that um, x is the MEX. So obviously for this x, you can just say answer plus equal to this count that we have got, and a count or count of subsequences multiplied with x. In this way, we will be able to find out the number of the basically the sum of MEX for all the subsequences. Now let's come back to the original problem. Here we don't have to find out the MEX, we have to find out the second MEX, right? SMEX. So main logic is the same. Now the thing is, the only different thing here would be for every x, instead of finding the number of subsequences where x is the MEX, now for each x, you want to find out count of subsequences where SMEX is x, है ना? Where the SMEX of the subsequence is x. Or in other words, you can say this thing as from 0 to x minus 1, there should be exactly one integer that is missing. Exactly one integer should be missing. Right. That's all we have to do. So it is gonna be a little tricky. Like not too tricky, just a little tricky. For now, let me do one thing. Earlier, as we had been finding out, for some element I we had been finding out the um, like you see earlier for some x you wanted if you had an array like 0 1 1 1 2 3 4, what you wanted to do was um you wanted to find one 0 at least one 1 and so on till x, you know. In general the code, like the example would look like this. Then you have x and then you have some um bigger people who you will still represent it. uh, like for the bigger people, you only care about the number of people who are bigger, even for SMEX, because whether they come or not does not really matter. But for the smaller people, earlier you wanted to have all of these. So if I say B, um, like I don't want to write 2 raised to the power count of I minus 1, this thing again and again. So for now, um, I will just say this thing as BI. Again, let's say that BI is the number of ways of choosing um, at least one occurrence of I. Let's say if it is something like this, BI is the number of ways of choosing at least one occurrence of I. So in the earlier problem, you just wanted to have all of these things true at the same time. You know, you had B0 ways for having at least one occurrence of 0, one B1 ways of at least having at least one occurrence of 1, and so on. It was like you have it was like you have 5 tasks: T1, T2, T3, T4, T5. and you wanted to find out the number of ways of having all of them true at the same time. But now what we want is, we want exactly four of them to be true at the same time. है ना? So either this guy would be missing, or this task 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 would be missing. Which is basically like, either you will have at least one occurrence of 0, at least one occurrence of 2, and so on till this, but 0 occurrences of 1, or 0 occurrences of 2, and so on. है ना? So let's take this simpler problem, which would be easier to understand first. Let's say you have 5 tasks, T1, T2, T3, T4, T5. है ना? The number of ways of completing these tasks are B1, B2, B3, B4, B5. So the total number of ways in which you can do all 5 of these tasks is B1 into B2 into B3 into B4 into B5. But if I ask you what is the number of ways in which you do exactly 4 of these tasks, then it would be something like, either you will do these 4 tasks, or you will do these 3 with this one, or these 2 and these 2, or this one and these 3, or these 4. So basically the answer here would be now B1, B2, B3, B4 plus B1, B2, B3, B5 plus B1, B2, B4, B5 plus B1, B3, B4, B5 plus B2, B3, B4, B5. है ना? Now this would be the answer, and you will have to calculate it in some way. For each of these B's, you can very easily find out the value of those B. That is not the trouble thing. The troublesome thing is, how will you find out this expression when you might have this value to be very huge? है ना? X might be something like 10 raised to the power 4 at some point. So you can't really run a for loop or do something for this expression. है ना? But like the way which I realized for solving this was, multiply B5 in both numerator and denominator, B4 in numerator and denominator, B3 in numerator and denominator, B2 both sides here, and B1 both sides here. So now this expression has become B1, B2, B3, B4, B5 multiplied with 1 by B1 plus 1 by B2 plus 1 by B3 plus 1 by B4 plus 1 by B5. Right. Since we have to find out the answer modulo something at the end of the day, so we can use the idea of modular multiplicative inverse, or modular multiplicative inverse. In case if you don't know about it, then please search about it on internet. There is a video made by Utkarsh Gupta with name CP Maths for CP. Even if you know about modular multiplicative inverse, but you have not watched the video of Maths for CP by Utkarsh Gupta, then I would recommend you to watch it out. It is a really good video. I did watch it when I was a beginner at CP, and it did help me out a lot. Nextly, I would also recommend you another resource, that is Love. You can just search Love CP on YouTube, and you will find out his channel. He has around 100 videos for competitive programming. I do recommend you to watch the videos regarding number theory and maths. I watched his videos for that playlist also, and it did help me out a lot. Okay, let's continue with the explanation. So earlier we just had this much expression. Now we have this expression. Everything else is the same, right? The only difference between the way how we were calculating the MEX and now we are calculating the SMEX is, earlier we just had the product of all of these ways. We had just this thing. But right now, we are having this thing along with this. So we can calculate this. Like in my case, what I did is, oh yeah, first of all, let's complete the expression, and then I will tell you how I did implement it. Baki, in my opinion, once you are done with how to, like, once you are done with the part of reaching an expression, the remaining part is not really that difficult to complete. So you should try to do it by yourself once. For now, the expression is for each x, the number of, like, the count subsequence here that we are getting is gonna be equal to pi of bi for I from 0 to x minus 1, right? That is this thing. Since I had named the task set tasks with one based indexing, that is why I used one based indexing here. But in general, we are having zero based indexing for the bi part. You know, we had zero based indexing here. Nextly, you would have to multiply with this stuff, which is nothing but sum of 1 by bi for all I from 0 to x minus 1. And nextly, we will have 2 raised the power count greater, right? We just have to find out this thing at the end with mod. So um, like we have actually realized, yeah, one more thing. We have to say answer plus equal to x into count of subsequence, right? So we are done with the logic part. You know, I believe you should pause the video at this point and try to implement by yourself. It might take you even 2 hours and you might still not be able to do it. But this is a very important thing that you should definitely try. That once for a problem you are able to think about the expression, you have figured out the answer in terms of a mathematical expression. Are you able to code it or not? This is something beginners do struggle at. You might code it and it may not work because you made some error while coding it, and then you spend time it debugging it. This is very important because if you don't try it right now, then in a future contest you might be able to get to the logic part, reach to the expression, and then you spend like 30 minutes coding it and then 2 hours in debugging it and you fail to solve it during the contest. So to avoid it, I gave my recommendation. Now let's begin, like, continue with the PCT. So for the part of implementing it, what I did is I created a variable with name prod, which is basically the short form of product, which will keep track of this expression. Another thing I created was with name, I think, harmonic sum, which is actually a wrong name, I think. I don't remember. I'm not sure if we call this thing as harmonic sum or not. Um, but during the contest, I just named it as harmonic sum. And for finding out this thing, I just kept track of this count greater. Right. So these are the only three variables that I did focus on to um, keep track of for all x from 0 to um, n or whatever. Right. Now, in my implementation, I did get a few edge cases. One of the edge cases was um, it was like if in an array you have something like 2, 3, 1. And now, when you talk about x equal to 0, you would see that it does not really exist. Like for x, you won't have the problem, but when you talk about x equal to 1, then you want to find out this thing and this thing, right? So b0 is just 0. There is no occurrence of 0. So obviously there is no subsequence which has 0. There is no problem with this guy where bi is just 0, but there is a problem with this guy. What do you mean by 1 by 0? What is meant by 1 by 0? I don't think 1 by 0 will give me an error. Yeah, it did not give me an error um, because of the coding template that I was using. But um, you see, you are able to realize that this is a problem. If there is some element that is missing in the array, there is gonna be b of I is gonna be 0 for that guy. So the product will just become 0. Harmonic sum will, I don't know what will become, what will it become? Because I don't know what will happen in case of 1 by 0. Will it be considered as just 1 or whatever in case of modular multiplicative inverse? But this is basically an undesirable situation because I don't know what is going to happen in that case. So to handle this edge case, I created a variable with name found 0. And in case if I find out that the frequency of some guy is actually 0, basically for some I, it is actually 0. So in those scenarios, I will not update the value of product or the harmonic sum. I will just increment this found 0 variable. And if at some point of time I find out found 0 equal to 2, like if the value of this variable becomes 2, in that case, I know that I don't really need to check for any bigger value of x because um, if let's say in the array 0 and 4 are missing, then checking for x equal to 5 is just rubbish because 5 can never be the second MEX. You know, second MEX would always be 4 for any case where 2, 3, and 1 are coming. SMEX can never be 5, right? So I just handled these two edge cases. Now, considering the fact that you're coming up for this problem, I believe this is something that would be doable for you. Very um, doable. Like this is a very doable thing. You know. By the way, for each x, we are having this expression where you have to calculate this. So please don't run a for loop for these. Just see, you have to find out some information from I equal to 0 to x minus 1. So you can create these variables product, harmonic sum, and count creator outside the for loop and just keep on upgrading, like updating those values so that you don't have to run a for loop for these expressions. And I believe like if someone is coming to this problem, he would be able to um, like understand at least this much that you don't really need to run for loops here. Right. So now let me show you my code. I'm just removing the unnecessary part from the code first. Okay, remove this, remove this. Then we have debug here. Okay, I don't have any debug now. Yeah. So see, first of all, I'm having a template of a template with name mint. The advantage of using a template is I will just create a variable with name, let's say mint answer equal to 1 whatever, or let's say mint prod equal to 1. Now, whenever I multiply this prod with some variable, let's say I multiply it with 10 raised to the power 6, it will become 10 raised to the power 6. It will just act like a normal integer. But the moment I multiply this again with 10 raised to the power 6, and the value exceeds 10 raised to the power 9 or whatever mod value I have set up, in that case, it will automatically find out its value with the mod. So it will automatically, like, if you have a mint integer, let's say x equal to 10 raised to the power um, 9 plus 6 or something, um, like 29 plus 6 or something, and you say x plus equal to 5, in that case, it will not become 29 plus 11. It will become 4. it will in itself just do modulo mod by itself. We have all the operators overloaded. So it reduces the chance of human error that we might get. If you're coding it by yourself, then you might have some human error. Now, this is the part of taking the inputs and finding the frequency of all the elements. I created a variable prod, I created a variable harmonic sum. Did I say harmonium earlier? Okay, harmonic. Okay, yes. Yeah, and I created a variable answer. Another variable found 0, and another variable count greater, which is initially n, which is keeping track of the number of people who are greater than the variable x. So I'm keeping track of these variables, like the value of count greater. I'm finding the number of ways with the same way as we had the equation. We have the product, we have this product, we have the harmonic sum, and we have 2 raised to the power count greater. Then I am incrementing answer like this way. Answer multiplied with, like, answer incremented with ways into x. In the logic part, I just named it this thing as count subsequence or subsequences, whatever. Code in the code part, we have the name ways. And nextly, I will update the value of prod and harmonic sum. And we had to take care of the edge case where product like bi might be equal to 0. This subs is basically the bi part. So this thing might be equal to 0. If it is equal to 0, then I should not multiply this thing into prod or something. So what I will do is just keep track of the number of times I have got the 0. And in case if this thing is not equal to 0, then I will update the value of prod and harmonic sum. And there was an edge case that I was getting where harmonic sum, the value of harmonic sum had become something like 2 or something. And once we find out a 0, like you see, yeah, we had this expression. You see, if any one of these is 0, let's say b1 is 0, then all the expressions in which b1 was coming, they are just basically 0 now. All the expressions in which b1 was coming, they are basically 0. You have only one expression left, that is product of all the other numbers. So in the code part, when for some number the variable was like bi was coming out to be 0, I did not multiply prod. But I have to make sure that the harmonic sum, the value of harmonic sum is also correct. So in my code, by just doing some hit and trial, I realized that, hey, updating harmonic sum to 1, if found 0 is 1, is gonna correct it. So it did work out for my code. As per your implementation, you might have to do some other if else conditions. You might have to apply some other if else conditions. And in case if I have found 2 or more people who are equal to 0, basically it would always be equal to 2, because as soon as I found someone who is greater than, sorry, as soon as I find out the second guy who is not coming in the array, then it is pointless to check for any value of x after that, right? And I'm decrementing my answer here because with my code here, the code that I've written, the we had to count only the non-empty subsequences, but in my code the empty subsequence would also be counted internally at some point of time. When x would be equal to 1, it will actually consider the subsequence where you don't pick either 0 and you don't pick 1, and you have the empty subsequence. So I'm decrementing the answer by 1 for that, and I'm printing the answer, and that's it. We have got the answer. And yeah, that's it. So let's end the PCD then. So guys, thank you for watching the PCD. Bye bye.